You know, there are moments in history that are just seared into our collective memory. January 28th, 1986. That was one of them. On a bitterly cold morning, the Space Shuttle Challenger lifted off, carrying a crew of 7 heroes, including Krista McAuliffe, the first teacher headed to space. And then, just 73 seconds later, it vanished from the sky. Now, we all know it was a technical failure, right? But the real story, the one we're going to dig into, is so much more chilling. It's a story about a tiny, simple piece of rubber, about crushing pressure from the top, and about a desperate warning that was completely ignored. All right, let's go back to that morning, January 28th, 1986. I want you to just picture the scene at Kennedy Space Center in Florida. You're thinking sunshine, palm trees, right? Wrong. It was so cold that there were literally icicles hanging off the launch tower. I mean, icicles in Florida. And sitting right there, ready to go, was the most complex, most advanced flying machine humanity had ever built. But it turns out, its greatest enemy wasn't some complex system failure. It was just the cold.
So how cold are we talking? The official temperature at launch was 29 degrees Fahrenheit. That's below freezing. For perspective, no shuttle had ever launched in temperatures that low. Not even close. And here's the really scary part. They had zero data on how key parts would perform at that temperature. Why? Because they never ever imagined they'd be launching in conditions like that. It was completely off the charts. So the big question is, why launch? If it's so cold and you have no data, why go? Well, you have to understand the pressure cooker NASA was in. This mission had been delayed and delayed and delayed again. First, a previous mission, Columbia, was late getting back. Then there were weather concerns at an emergency landing site in Africa. Then the weather in Florida was a no-go. Then there were high winds. At one point, they couldn't even close the hatch because a handle was frozen. It was one frustrating thing after another, and this unspoken feeling was building. We have to get this bird in the air.
You know, it's incredible when you think about it, the space shuttle. I mean, this was the pinnacle of human engineering. Millions of parts, incredibly complex computers, the most powerful engines ever built. But its fate, the lives of its 7 astronauts, didn't hinge on any of that complex stuff. Nope. It all came down to one of the simplest, most low-tech parts on the entire vehicle, a single fatal flaw. Its Achilles heel.
So what was it? It was this, the O-ring. I mean, look at it. It's basically just a big rubber ring, a glorified seal. There were 2 of these inside each joint of the huge solid rocket boosters. And their job, while simple, was maybe the most important job on the whole shuttle. They had to contain a 5,000-degree jet of burning gas. Think about that, 5,000 degrees. If that seal failed even for a fraction of a second, well, the consequences were unthinkable. Okay, so here's a diagram that shows you exactly where this O-ring set. You're looking at a cross-section of the booster joint. When those rockets ignite, the incredible pressure inside is supposed to instantly squish that O-ring into the gap, creating a perfect seal. See how it works? It's a simple, elegant design. But again, it's a tiny little piece in this gigantic puzzle, and everything, absolutely everything, depended on it doing its job flawlessly.
And this slide is the key to the entire disaster. It all comes down to high school physics, really. When the O-ring material is warm, it's flexible, it's bouncy, like a rubber band. It can snap into place in a split second to make that seal. But when it gets cold, it totally changes. It becomes stiff, brittle. Basically, it turns into a hockey puck. And a hockey puck isn't going to seal anything. On that freezing morning, those O-rings were too stiff and too slow to seal the gap. It's as simple and as tragic as that.
And here's the thing that makes this so much worse. This was not a surprise. It wasn't some unknown theoretical problem. Just listen to this quote from astronaut Don Lind, talking about his mission less than a year before Challenger. He said, "The first seal on our flight had been totally destroyed. If it hadn't done that in the next 200 to 300 milliseconds, we'd have exploded." I mean, can you believe that? They had a near miss, a dress rehearsal for disaster. The data was there, the warning signs were flashing bright red. Okay, so this is where a story about physics and engineering turns into a story about people, a human tragedy. We're going to the night before the launch, to a teleconference call where a group of engineers desperately tried to stop what was about to happen. Now, normally, before any launch, the engineers have to answer one question. Prove to us that it's safe to fly. The entire burden of proof is on safety. But on this call, something incredible happened. A NASA manager flipped the script. They basically told the engineers from Morton Thiokol, the company that built the boosters, you need to prove to us that it's unsafe to fly. See the difference?
It's a subtle change in words, but it changes everything. The engineers were being asked to prove a negative, using data they didn't have because it was too cold. That single shift in language, that's what doomed the Challenger.
And the pressure on these engineers was just immense. When they first presented their data and said, "We can't launch," one of the NASA managers, George Hardy, shot back with this. He said, "I am appalled. I am appalled by your recommendation." He wasn't appalled by the data showing a potential catastrophe. He was appalled that the engineers were suggesting a delay. Under that kind of pressure, the managers at Theacle caved. They overruled their own experts and told NASA to go ahead.
So the next morning, 11:38 a.m., against the engineers' warnings, Challenger cleared the tower. Let's walk through those final 73 seconds.
It's almost unbelievable, but the failure happened almost instantly. Less than a single second after ignition, the fatal flaw had already appeared.
If you look at the launch footage in slow motion, you can see it. 8 little puffs of dark gray smoke from the aft joint of the right solid rocket booster. That was it. That was the moment of failure. The cold O-ring didn't seat properly, and 5,000-degree gas was already leaking out. But in the thunder and fire of a shuttle launch, nobody noticed.
Now, for almost a full minute, it looked like they might get away with it. Miraculously, a temporary plug made of aluminum oxides from the propellant actually sealed the hole. The shuttle kept climbing, everything seemed fine. But then, as Challenger hit the period of maximum aerodynamic pressure, max Q, they call it, that fragile plug was blown away.
And at just under 59 seconds into the flight, the leak reappeared. But this time, it wasn't smoke. It was a visible, well-defined plume of flame, a blowtorch, essentially, erupting from the side of the booster, and it was aimed right at 2 critical things: the massive orange external fuel tank and the strut that attached the booster to that tank.
And the most chilling part? Inside the cabin, the crew had no idea. Everything was perfectly normal. The last clear transmission we have is from Commander Dick Scobie. He just calmly says, "Roger, go at throttle up." They were hitting the gas, right on schedule, completely unaware of the catastrophe unfolding just feet away.
And then, at 73 seconds, it happened. The image that everyone remembers. The shuttle disappeared into a giant cloud of smoke and fire. But it's important to understand, it wasn't an explosion like a bomb going off. It was a catastrophic, violent breakup caused by incredible aerodynamic forces.
So here's what actually happened. That blowtorch flame burned through the struts and the side of the fuel tank. The booster broke free and smashed into the tank, and the whole vehicle, traveling at nearly twice the speed of sound, was instantly torn apart. But the crew cabin, which was heavily reinforced, actually survived the initial breakup. It broke off in one piece and continued to fly upward, carried by its own momentum.
For a long time, the story we were told was that the crew died instantly, painlessly. It was a small comfort in an immense tragedy. But as the investigation dug deeper and they started recovering the wreckage, a much darker, much more difficult truth started to emerge.
Okay, this is hard to talk about, but it's important. The investigators were able to piece together the final moments of the crew cabin. After the breakup at 73 seconds, it kept climbing for about another 20 seconds, reaching an altitude of over 64,000 feet. Then it fell. For 2 minutes and 45 seconds, the cabin was in a free fall. It hit the Atlantic Ocean at over 200 miles per hour. The evidence showed the crew survived the initial break.
The official investigation that followed, the Rogers Commission, was, well, it was a lot of bureaucracy, a lot of charts, a lot of finger-pointing. But one person on that commission, the legendary physicist Richard Feynman, was having none of it. He was going to find the simple truth, and he did it in a way no one would ever forget.
So right there, in the middle of a televised public hearing with all the cameras rolling, Feynman did something amazing. He asked for a glass of ice water. He took a sample of the O-ring material, squeezed it in a small C-clamp, and then just dunked it in the ice water. After a few seconds, he pulled it out and took off the clamp. And nothing happened. The rubber just stayed squashed. It didn't expand. It had lost all its resiliency. In that one simple, brilliant moment, he showed the entire world exactly what went wrong. No charts, no techno-babble, just a glass of ice water and the simple, undeniable truth.
And that demonstration led to Feynman's final, powerful conclusion in the Commission's report. He wrote, "For a successful technology, reality must take precedence over public relations, for nature cannot be fooled." And that's really the lesson of Challenger, isn't it? It's a heartbreaking story about what happens when public relations, when schedules,
when pressure for management are allowed to overrule reality. It's a reminder that no matter how much you want something to be true, you can't fool nature. You just can't argue with the laws of physics.